Okay, let's get going and get started. Thank you everyone for joining us this afternoon. Hope you're having a great afternoon. I'm filling in for Scott, in case you're wondering who this guy is, who's here. I'm not Scott, I'm Angus McDonald. If you're wondering about Terum, we're a product development strategy firm working mostly in Sydney, but we've got presence all across Australia, New Zealand, and a little bit in California. We work with enterprises, startups, government. We've worked with the likes of QBE, the ATO, Immutable, as just some of the organizations we've worked with. And we're at our best when we're helping people develop product, working with you on strategy and helping uplift internal capabilities. A little bit about me. I'm Angus McDonald. That's me enjoying the northern beaches of Sydney. There is a bit of a bushfire I just noticed in the background, which I forgot about when I took this photo. I've had senior product and technical roles in a number of different companies, most notably probably Technology One, Objective Corporation, and have been in the biz for quite a while, quite a few years. And I'm a new fur dad. Melanie got that out of me, our events manager, and a keen amateur sailor. And I'd like to introduce Chris Sampson. So Chris is CTO and co-founder of Tiliter. They're a world-leading provider of AI product recognition solutions, and we'll talk a lot more about that. He's built their engineering R&D team for the last 4 years, from a single engineer in a garage to a global technology company. He's an expert in AI systems, algorithms, and signal processing, and has a passion for music creation and fitness. So without further ado, what I'll do is I'll stop the slides, because really it's all about chatting to you, Chris. Thank you for joining us this afternoon.
Awesome, pleasure to be here. Really excited.
Yeah, good. I think we'll cover some good ground. There's nothing. Can you just start maybe by telling everybody what Tiliter does? Because image recognition is, well, it's a big field.
Yeah, sure, absolutely. Yeah, so Tiliter, we, as you mentioned, we build AI product recognition solutions for retail in particular. We're really focused on the retail space. And basically, we provide recognition software and also hardware into retail environments to do mainly fresh produce recognition, but also nuts and confectionery, bakery, any loose items that traditionally you need to use a lookup menu or have the cashier remember a PLU. I'm sure everyone's used the self-service checkout and search through the big long menus. Basically anywhere you need to do that, our software is able to be integrated and do that recognition automatically using AI. So as you mentioned, we've been running for about 4 years. We started really at the beginning of, it was very interesting, the timing at the start of our business, I guess, was the beginning of, I like to talk about the AIoT sort of revolution, where it was, you could start running these really heavy AI models on the edge. And that's really been a big backbone of our business. So you can see our product out in Woolworths. If you ever use Scan and Go, there's vegetable scales in the fresh produce section that will automatically identify your items, support the Scan and Go process. There's a number of installations on self-service checkouts and standard checkouts here in AU. We also have some product in the EU and in the US as well. So we're kind of really on the cusp of I guess, that next phase of growth for ourselves in our business. But we've had product out in the field and been supporting that for some time. Really excited. I guess, the topic of this conversation really about that edge AI. As I mentioned, for us, that's been a really big part of our business. It's something we focus on. We build our own edge processors in-house, and they're the heart of all of our technology that sit there. So plenty of insight that we've had over the last 4 years dealing with that stuff.
Yeah, I mentioned to you, I've used the Scan and Go at Woolies. It was kind of a COVID novelty that came in, and it is like barcodes for fresh produce. Put your bananas on, put your capsicum on, have it recognize what you've got. It brings up a little thing that says, yes, this is what it is, how much you've got there. So it was really, didn't realize that was a Tiliter product, but yeah.
It's interesting with Scan and Go, because I think Scan and Go, it's one of those technologies. For me, it's probably the best alternative to fully autonomous shopping. that's out there, because the infrastructure is already paid for. Everyone already has a phone. So anyone in the audience who hasn't used it, I encourage you to get out there. It's in a lot of stores in Sydney. I believe at least one store in every major centre in AU, and also in Countdown in New Zealand as well. So you'll find those scan and go systems out there, and yeah, give it a go. It's a great way to shop. Shopping on your phone. You don't need to unpack the trolley when you exit, which I thought that was a big thing, you don't think about it, but if you don't have to unpack your trolley, you're just basically scanning as you go, and then out you walk. It's really exciting. But for us, our part of that technology was really about streamlining the process, using the artificial intelligence recognition, turning what was a two-step process into a one-step process. And yeah, as you mentioned, I guess for us, really the best way to think about tech is really a barcode scanner for fresh produce or things that don't have barcodes on them. So as you mentioned, there's a lot that can be done with computer vision nowadays that you couldn't do, certainly 10 years ago, but even 5 years ago now, doing it in the way that we're doing it on the edge. That's a big part of it. It's about doing it fast. It's about having the system, it's not connected to the network. You're not running a cloud server. It's right there. It's ready to go. And believe it or not, in the retail environment, it's really important. It's really important to have speed, particularly at the checkout. That's what a lot of our customers talk about, is about the speed of the recognition of the checkout. So
was that something you had first up? Was that a like out of the box when you knew you had to have speed and edge, or did you find that out perhaps as you talked to customers? How did you guys get into edge and all that?
Yeah, like I said, so the timing of our product development was really interesting, I guess. So we started the company in 2017, late 2017. We were really all sort of full-time into it, and running a real business in 2018, putting our full-time jobs and diving deep. But it was definitely part of the thesis initially. We were at that time, if you think back to 2017, 2018, there wasn't actually a lot of edge accelerators available. If any, there were a couple of niche things, but there wasn't really anything commercial. I believe it was mid 2019 the TPU came out. So it was the Edge TPU, the first versions of that, where you had the USB. So again, anyone sort of who's listening to this and is familiar with that IoT AI space, the TPU is an edge accelerator. That's really, when we talk about edge, it's about edge acceleration, for ML devices. So that was when we started. That didn't exist. We were running mobile nets on basically a Pi, Raspberry Pi platform, and that was something that, yes, when we traveled around and we sold that to the customers, it was very exciting, because they I guess told us that if in that retail space it's difficult to get network connected systems. Security in those environments is generally by having an enterprise network that has limited outbound connections, and in the early phase of when you're, I guess, getting a product off the ground, getting connected to networks in those environments is very challenging. I'm sure it's the same we've done a little bit in logistics, but I'm sure it's the same for anyone who works in manufacturing. Really, any big enterprise network is going to be challenging to get devices connected to the internet. So when we were selling that, we could run this state-of-the-art deep learning on a small, cheap PC that was completely disconnected from the outside world. That was exciting. People were listening, and it was telling us that, yeah, this is the right thing. In the past, I don't think even at that time there were really any cloud-hosted sort of solutions doing similar to what we were doing in that checkout space. Again, people don't realize, but if you've ever worked in that retail space, my first job, actually, believe it or not, was I was a cashier. That was my first high school job. And it's funny how it comes full circle. I never really thought about that until a few years into the business. People were like, "Oh, how do you?" I was like, "Yeah, actually, I worked in this space." Actually, so you measured on speed. Particularly European retailers, where there's a lot of discounters. So if you ever shopped at Aldi, how fast the cashiers are. You feel like you're under the pump getting out of the store, because it's about speed. That really translates to efficiency inside those stores. So if you're talking about putting software onto checkouts, and you're relying on cloud-hosted systems, that are network connected, it becomes a big battle. So the short answer is
right.
yeah.
A lot of latency, a lot of waiting for results, and yeah.
That's right. Yeah. And then, like I said, in that early phase, actually, when we were trying to, I guess, prove the use case and get technology over the line, it's the overhead of actually getting connected to those networks, didn't really outweigh, the cost benefit at that time, because we were still discovering that. So the short answer is yeah, it was really important. It was really important, and I guess it was something that we I guess it was easy for us to go and demo systems. We could just take the system around and show it working. But it was always about the edge processing, and that's a big opportunity still. Not just in that fresh produce space. It's really exciting.
And is it I guess it seems like a very scary thing what you guys do, because we talked the other day. It's the scales that are in Woolies for Scan and Go. That whole product is yours. It's not just the software piece. It's the hardware piece as well. And I know that, talking to other CTOs, that always seems to be something people are skittish about. Like we understand software, you throw in hardware and it sounds like it's another much more difficult problem.
And it is. Anyone in the audience who's run a hardware business in the past knows that it's called hardware for a reason. It's pretty hard. It can be tough. I mean, it comes with its challenges, and I guess for us, the team that we have, my background has always been hardware. So I was traditionally an electrical engineer, so that was my bread and butter. So I was always involved in hardware, and sort of became a software engineer, and across the signals and systems side later in my career. I was always a part of the early phase, but it wasn't sort of something that we were necessarily afraid of. So I think if it's something you've dealt with in the past, it's something you know how to wrangle. But there's for us, you talk about the scales in the retail space. It's really you've got compliance issues. Our scales are fully NMI compliant, so it's the same body that looks after your petrol bowser to make sure that you're not getting overcharged for fuel and things like this, and they come down pretty hard on those things if they're wrong. Not only on us, but also the customer as well, the actual retailer, if there's any issues there. So look, it's not something to be taken lightly, but at the same time, from a product point of view, and what I really think, we talk about edge and having that hardware, it's sticky, and we have products that are going to be in stores for 5-10 years. Which is good and bad. It's good and bad. You've got a good opportunity to continue to upsell in terms of features and maintain, but you have to build that hardware. So for us, it was a necessity. And if I touch on I guess a lot of businesses sort of or a lot of customers, I should say, ask is when we first kind of, I guess, started, proposing some of this stuff and particularly the edge processes and things like that we were doing. When we first started, there just wasn't solutions that were enabling this. And even today, right. It's like we have the most advanced vegetable scale globally. Really, it's something that with the edge power that we have inside, it's something that we're kind of leading the world in. So it's like we kind of had to build it out of necessity. So sometimes you have to do that, I guess, if you want to achieve the mission of the business, which is to deliver this recognition in store. I guess it's something that you shouldn't be afraid of. But it comes with the challenges, definitely, and be prepared for that for sure.
You mentioned that you're not joining the Wi-Fi network because it's getting inside the enterprise network at the retail end is its own kind of hurdle. Did you have connectivity? Do you have connectivity to the machines if you have to redeploy models or update them? Or
so we do generally now. We do have connection to the Wi-Fi for inside many of those large retailers. The key is that the system doesn't need that connection. It can be disconnected at any time. So there's a few things, I guess. And I guess when you talk about edge AI in general, I mean, depending on the environment, I mean, that's certainly one. And I think when we first started, it was good, but that carries on, into other areas, that the system doesn't have to be connected to the network. And that's good because you don't have now this vector that, it's a way to get on to the network if if it's connected generally, the whole fish tank, hack through the fish tank sort of scenario, that is a real problem with some of these devices if you're not careful, getting these devices on the network. But generally,
so when you say hack through the fish tank, is that having a smart fish tank that then is hackable?
Yeah, I think there was a story about a casino getting hacked through one of the fish tanks, and which was part of the network. So when you talk about IoT, these generally these devices are going to have the sort of lowest amount of security controls on there. So they become a vector if they're connected to the network. If the device doesn't need to be connected to the network, that's great. Then it means it can run in operation completely, disconnected. But in our case, now say the scales, for example, they are connected, but we don't need to be pushing inference, and that's another one, which is that latency factor. So again, if you're working in this space, you can host a lot of this stuff. Obviously, the ML, a lot of ML applications being hosted, in the cloud, and that's one way to do it. But if you've got sort of applications that need good reliability, latency, it can become a challenge. And even some of the places that we put systems remotely, it's a big challenge. Network bandwidth is actually a real problem. So the ability to do all that inference on the edge is important. So there's a few layers there, I guess, I'm talking about. So if I think about that advantage of edge, for me, it's the security, it's the reliability, and it's the latency. And depending on the application, it may, some applications, for example, again, in manufacturing or defense or various sort of applications, getting network connected may not be a possibility. And I think that's where edge is a great.
Did you use 4G in early days? Was that like
we did? Yeah, we did. Yes, absolutely. So a lot of our systems were connected on 4G, and that's one where if we we had trouble just keeping those devices connected. If anyone's used 4G to kind of keep depending on where you are, some of the stores are in the city, like underneath buildings and things like that. It's not as reliable.
They're in the basement, right? So it's not exactly a good location. Yeah.
So Wi-Fi, I talk about this in one of the blogs. I think there's this conception that Wi-Fi is we use it so often, and I guess what you don't realize is a lot of the applications that we use have a lot of, I guess, buffer for this. The latency is not as, there is room for latency. There is room for, dropping packets and various things like this. But it does happen, and Wi-Fi, particularly 4G, in some areas, it isn't as reliable as you'd think. And when you're talking about doing, industrial level applications at scale, you just can't, you can't rely on that. Like a lot of the retailers just say, no, we don't want Wi-Fi. It's all about Ethernet connection. We want hardwired connections. If your only option is to go to Wi-Fi, or 4G, it may not be an option. So that's again where edge comes in. If you're relying on doing inference over the cloud, it may be a showstopper for you.
Yeah, right. And how much of this did you work out by talking to customers? Like you mentioned that you've got customers in Europe and customers around Australia. Have you done roadshows, or how have you gathered that kind of feedback from them?
Yeah. And that's where I guess it's always one that comes up. I guess, when we talk about our journey and talk about why edge for us, why edge is so important. It is through that, it is actually talking to the customer. In the early days of the business, we literally traveled the world talking to every vendor we could, the world leading vendors in barcode scanning, in POS manufacturing, in retail, and these are the things that stick. And I think I remember particularly one of the customers we kicked off with having a look at the solution and saying, hey, so this is I don't need to connect anything else. This is it. This is all I need to do. Yes, good. Okay, that's good. We want to do that. And it became a real advantage. It was a real advantage for us. I'm talking about real AI, real deep learning, powered systems that didn't need internet connection, that could run offline and could run on really what was quite a cheap, processor unit, which had an edge accelerator inside. Before then it was different. So it was definitely something that the customers were telling us was important. And again, that's what I'd say. As the CTO in the business, I guess for me it was an interesting journey because it's an obvious, even to a point. I mean, a lot of retailers talk about, and a lot of customers and vendors talk about even having centralized units. The idea that you have, we have a dedicated unit, say per POS system or per scale. Just the modularity of that, the way the customer thinks about that I don't need to manage. There are definitely those retailers and vendors out there who are going to a more server stack system where you can run all of your applications on maybe a single install. And technically, I mean, this is still part of edge. This is still part of edge computing, where you're actually having a server inside the store. But even then, the complexity of the network, you got to remember, like some of our customers, retailers, they're not, super advanced in terms of their IT capability. And they really pinch pennies on some of this stuff. It's a low margin business, particularly, as I said, in Europe, it's really about being discounted. So yeah, the idea that we could do this, and it was quite modular. It didn't need internet connection. They weren't needing to worry about overheads and the security of the system and adding different things in. It was it's proved to be a continuing advantage. And look, will it be that way forever? I certainly see that for some time. I think there's an idea that everything will go to cloud at some point. I think there's a lot of applications where, again,
I think it's the swings and roundabouts. Goes to cloud, comes back out of cloud, goes.
It does. I mean, and for some applications, it just doesn't make sense. Again, I always talk about the barcode scanning. It's like the barcode scanners have a processor inside of it. It's like, you could technically centralize all that, or you could have a camera, but it just doesn't make sense. Retailers want systems that you're only going to look at the POS, for example. You have a PC for every application. There's a reason for that. It's about reliability. It's about ease. Switch things around.
Makes it
having
simple.
it run locally makes sense.
So as CTO with your team, are they all data scientists? Are they all hardware nerds? What's your kind of ratio? Is it?
Yeah, no. So it's quite a mix. Obviously, the fact that we do build end-to-end solutions, it is quite a mix. So we have about 20 to 25% of our team data science and ML. So really working on the models, and we do all of that in-house. So from really the inception of the company, our secret sauce, so to speak, is really about the way that we, are able to expand data sets. We do all the data simulation and data expansion to maximize performance without having to do install collection and various things like that. So it is a big part of our business, and we really, we build that in-house. It's something that we don't outsource any of that. It's a really core part. However, the other part of the business, with the hardware and the software that we do, the supporting systems, it is a big part as well. So, like I said, 20, 25%. The rest is you're looking at hardware engineers. So we do have mechanical engineers, hardware engineers looking after compliance and the hardware designs that we have for the systems as well, cameras, various things like that, lighting. And we have our infrastructure guys as well. So we do have an internal management system for our edge devices. So managing the deployments, managing the reliability of those systems, getting data back. We have some infrastructure for that. And then you have your device and software guys as well. So the actual software that sits on the device to do that. So it's a bit of a split. It's a little bit of everything. If you're building end-to-end systems, there's everything from, like I said, infrastructure, the ML, all the way to the front end that sits on the device. Again, if you go into store and check out some of these devices, the front end that you'll see, that's all ours. It's a web front end that we build, and all of that comes out of the engineering team.
Okay, so so you need to have a full range of skill sets in there. Still, it's quite, 1/4 or so being ML, so that's still quite a heavy amount. Are there weirdities that you need to deal with, like, fruit and veg in Europe looking different than it does in Australia, or?
Oh yes, definitely.
Odd local things.
Yeah, 100%. It's I guess it's one of those areas that we kind of, discovered as well, and I think you'll find, we weren't the first company to try this solution, and people ask us still. I mean, we have such great technology, we have such a great infrastructure pipeline, but we are quite focused on getting this fresh produce problem solved. It's a global problem. Every supermarket you go into in the world, faces this same challenge. And it's solved either by cashiers. We have these menus on self-service checkouts, and I think it's kind of like it's crazy because it's such an obvious problem, but yet it hasn't, until recently, hadn't been cracked. You couldn't do it with methods that were not using the stuff that we have today. The latest in AI ML. That's given a step change in terms of recognition. But then stepping down a little bit more, you find these intricacies in terms of, okay, a gala is called gala in the US, but it's Royal Gala here. There's marketing names. There's slight differences in the look of, say, a nectarine in Europe versus here. They're slightly more spotted. Actually wrangling that and getting that right for us has proved to be an incredible strategic, advantage. Because it's the kind of thing that you can't solve it until you solve it, and it hasn't been really solved at scale because there's been no reason to do it. So there's a few bodies out there that, if you look at say PLUs for example, they've started some of that. So PLUs are supposed to be sort of internationally standard, but you'll find that they vary. People use them, sometimes they don't. There's no real reason to kind of consolidate that information. And if you look at sort of our long term, it's a real opportunity actually to get that standardized across the globe actually, because we envisage at the end when we're done, we see this fresh produce and loose item recognition as just an off the shelf piece of software that is able to recognize every piece of item and can be configured.
How do you demonstrate accuracy to customers? Do you have to do the give us 100 pieces of fruit and we'll show you what they are, or is there a standard for this today that you can talk about? And is there an image recognition standard or
no? And this is kind of what I'm talking about. For us, there's an opportunity. We're kind of defining some of that right now. We're defining kind of this space. In terms of demonstrating accuracy, it's usually going into a POC. In the early phases, basically, hey, let's install some systems. In a lab, they go and buy their fruits and they put some down. And they let us know what works, what doesn't. For us internally, obviously, we have a process for that. We collect our own test data and validate that against field data and things like that. In terms of showing that to the customer, it's about getting it in front of them. There's a skepticism around this technology and a stigma because of the failings of other solutions in the past. Like I said, we're not the first flavor of this technology to have been tried, but our timing was such, with the deep learning systems that are available, that we're able to be quite a lot better than anything that had been done in the past. We're able, generally we'll be taking that into customers and showing them this sort of stuff, and that's where you'll find most of the fresh produce is standard across. If you go to the US, you go to Europe. Broccoli's broccoli, capsicum, they call it, peppers in the US, but they look the same. So that's just a mapping thing. But it's the varieties that sort of, some of the apple varieties and things like that, where they'll have niche varieties where we will generally, they'll come back and say, hey, this one's not working. Yep, okay, we need to go and do some data collection or whatever the case is. But generally nowadays we can show quite good performance in pretty much almost all the regions because we have quite a large data set and we cover, I would say, definitely 90% of your most purchased items across any retailer in sort of, a developed nation.
Yeah, definitely. One of the questions that's come from the audience is, we've mentioned ML, we've mentioned AI. They kind of get used interchangeably as terms. How would you explain to someone the difference between ML and AI as a general concept?
Yeah, I guess it's a good question, and I think it depends on it's a very contextual one. I think ML is really about training systems to learn parameters using data, and I guess AI for me is really where those number of parameters is quite quite large. I mean, there were we were touting sort of AI systems that we had systems that were AI 30 years ago, an automated system that just opens the door based on a sensor. Some people call it AI. Maybe not. I think that the ML is a little more specific. I think ML is really about machine learning is really about training a model using data, and there's obviously a line between some statistical methods that fall into that. Even to an extent, I talk to the team all the time. To an extent, curve fitting, drawing a regression line is to an extent can be considered ML, but it's probably a bit stretchy. But is that AI? Well, not really. Again, I think that the term AI sort of constantly sort of evolves with whatever the latest and greatest in algorithms is. That's probably where AI kind of sits. So I think the AI term is a little bit contextual depending on the time.
It's a bit broader. Machine learning's nice and specific because it's talking about what the task is. AI could be any sort of task. It could be a movement task. It doesn't have to be recognizing inputs as a particular
and look, I guess
you can be deciding what to do.
It's definitely AI. It's a marketing term. I think every it's like if you talk about where you raise, you got to have AI in your company nowadays to to raise a round of funding or whatever the case is. But look, I would say for me, it's really about the complexity of what you're trying to do. And look, I think definitely nowadays AI and ML are kind of synonymous, not by sort of necessity, but it's just that generally wherever there is some AI, that's what we would consider AI. Generally, the backbone of that is going to be some form of ML, where you're training a system, to learn the problem space rather than coding it and actually developing that as a system of processes. So yeah.
Yeah, there was another question which is about, can image recognition help with some of the problems we have with scanning old documents? And I know for my background's document management, I as a product manager, I had lots of people trying to sell me AI-enabled solutions for it. It depends on how much you want to rely on AI for that, and it depends on your source data set. So one of the issues about documents is a lot of people train AI on academic data sets, which is fine. They're very easily available and very easy to get mass numbers of documents of. But if what you're dealing with is something that's less like that, like it's a technical document set, or it's more social, it's people writing emails to each other, then you might find that that image recognition doesn't work as well because it's been trained on the wrong model. And I guess that like you couldn't, the data you train on is what makes your machine learning so good, Chris. If I
yeah, look, it's an interesting one, and I think the one thing to like AI, today, it's particularly these recognition problems, and we're in that space. There are some problem sets that have large amounts of data that I think there's a real movement at the moment in this space about being data centric in the way that we're developing ML. And the theme is essentially that in terms of models, in terms of actual recognition models, we can, and this is sort of pushed by a lot of the leading academics in this space and people who are on the ground actually dealing with this stuff. We're in that boat. Is models are good. We've developed really great models, CNNs, convolutional neural nets, and various frameworks that work very well. And they're kind of almost commoditized at this point, I would say, for a lot of problems. The challenge is in getting the data, getting data for the problem that you have. And I think, this one, for example, the document space one, for example, is an area where there's good labeled data sets. So you can probably do quite well, translating some of, because the data set's so large, and so I guess it covers quite a wide domain. For our problem, for example, we actually collect all of our own data. So all of the data that we collect, we don't use any data from online services, Google or whatever. When we first started, it's like, I can't just go get thousands of images of, I can type in apples. Thousands of images of apples and bananas in Google. Can't I just train that way? Well, the domain doesn't match. So you can't, and that's one thing, I guess, AI and the current, particularly in computer vision, the things that we can do are pretty amazing, but they're only as good as the data that they're trained on. And some of those bigger systems, you talk about other areas, say, language processing, so the GPT-3, for example, that's been trained on huge data sets, and you get massive return out of that. There are so many problem areas, that don't have that amount of data, and it still remains a challenge. There's a lot of opportunity there. But the good news is we have the models. So if you have the data, we know how to, and this is, 10 years ago, 15 years ago, we didn't have those models. We couldn't actually we had the data, but we couldn't get, the systems to perform and deliver the level of performance we can get now if we have the data. But it still remains that the data itself is important. So I was just like, if when we talk about where ML is and where I guess computer vision is today, it's like, I don't think there are many areas that the technology that we have can work for. It's just, can you get the data? That's the real thing. It's very interesting. If you think about an area, say for example, manufacturing, defect detection. One of the big problems they talk about there is there's not a lot of positive data. So if you have a very good manufacturing plan, you
Right.
actually don't have a lot of bad data. So it's hard to get.
Yeah. We haven't got enough defects to train the defects.
Yeah, that's right. If your manufacturing line's any good, you don't have enough defects to actually generate the data to train your model. But the technology can do it if you have the data. So that's where that push has been about data centric. So, in terms of like back to the question about scanning documents, and we get this question, bakery items, things like this. It's really about what we can get our hands on and train data for. And for us, the inception of our company was about actually being able to do that on low numbers of data, so we could train our models using and particularly using simulation. It was really about data simulation, so simulating a lot of the variance, because you're trying to get data across a wide domain. That's kind of, you need to kind of show. I use the example, chatting to someone the other day. It's like if you train. I think about these ML systems like a child. If you train your child to learn to ride the bike in the backyard, and then you put them out on the road, it's probably not going to be a good time. You need to
right.
you need to give the child a chance to learn that environment, and it's very, very much the same. The domain, giving the ML an exposure to that domain is really important. Transfer learning helps. Transfer learning is, but at the same time, there needs to be some domain crossover in order for you to get.
So in the early garage stage, was it the co-founders bringing their groceries in and going, well, here's what I bought this week, and
yes, very much so. Yeah, absolutely. That was and still today, we do data collection. There's no shortcutting, I guess, this area of collecting data. You can we aim to streamline it as much as we can, but when a new fresh produce item comes in, we go out and we get it, we buy it. If there's a new variety of apple, for example, we get it, we buy it. And we know that process that we have, from getting the item, training it, delivering a model works. It's just, you still need to do it. So when we go into new regions, collecting is pretty important. It's a pretty important part of scaling the technology. And again, it's proving to be for us a very interesting strategic advantage. We have quite a large data set. We're familiar with the lay of the land in terms of fresh produce globally, how things match up. What's important is if you get that wrong, if you don't do that and you just kind of, hope that, let's say, for example, you have a category that you in one region that is the same as in another one, but it has the same name, different name, sorry. It can really ruin your ML. So you really need to be across that. So
be careful what you're doing.
Yeah, a good example is persimmon and kaki. So persimmon, the small yellow, almost looks like a tomato. They're called kaki. It's K-A-K-I in Europe. So initially, when we first started training, if they're separate categories, the ML doesn't know what to do. It's quite you kind of it's trying to split hairs. So you have to be quite across that when you're training these models. Yeah,
okay, that makes sense. And so you talked about the technology back then, very primitive. Now, much more up to date. Where's AIoT today? Like if one of our listeners is saying, okay, I've got an idea for edge computing, what do I get into? It's not Pi raspberries and
look,
that kind of stuff, or is it
there's definitely, so it's definitely come a long way, and we so there's a lot of now edge accelerator options out there. There's a lot more niche ones coming out even by the day. This space is starting to pick up again. I guess it's kind of in that normalization phase, I would say now, where people are starting to. There was a phase where a lot of the stuff that came out, the TPU and a few different things. Intel had the NCS2 chip as well, which that was in the early phase, was kind of like tinkery stuff. Getting people up to speed and I guess just generating a community around some of this stuff. And in the early days, I remember even getting some of these things running was a real pain. Like the drivers and things weren't that mature. Now it's better, and there are a number of edge hardware options out there. So someone getting into this space, if you're looking at projects in this space, generally, for most of your applications, you'll find that there's going to be some kind of solution out there. So ASUS have a number of offerings. The Pi is still a good option, and we still use the CM3 chip in a lot of our devices. It's the more industrial version of it, not the Pi, but it's an incredible platform. The Pi platform is really mature, even from a security standpoint, from a compatibility standpoint. I would recommend that platform to anyone who's getting into this space, because the support that you get there from the community that's built the tools and the drivers and the plugins and things like this, it's huge. Even the camera, the applied camera itself is really, really good, because that's another big thing that I think that's probably remains the biggest challenge in this space. If you're doing computer vision, is the camera. The camera is so important, particularly for our application where, we're trying to tell the difference between very similar looking items. You need that to be consistent. We have our lighting system, which is consistent. So that remains a big challenge. If you're doing things like people tracking, vehicle identification, scene assessment, that sort of thing, you'll find there are a lot of options out there. Intel have a lot of cameras now, depth cameras that are really great off-the-shelf type cameras, and it's really about combining that with the edge options out there. Another platform that we use is the Jetson Nano, and really the flavors of Jetson. There's a few flavors of Jetson. The NVIDIA accelerators that are out there. So the short answer is yes, the space is much more mature. However, it still has a long way to go. I would say there are still big gaps, and we still wrangle them today in terms of things like deployments. There's a few platforms out there. Those of you familiar with IoT space, IoT Edge in Azure is quite, it's mature. We used that very early on, and it was difficult with it wasn't compatible with some of the hardware that we had. So it was, these are the things where you be careful when you're starting in this space, because you end up having to, deal with a lot of the problems that the community may not have solved yet. This drive is not compatible with this piece of peripheral device. The other one is Greengrass on AWS. We're starting to move to that now. So there are good platforms out there that allow you to manage deployment and the device management. But I would say it's not at an industrial scalable, space where people can just pick it up and go. You still need an engineering team who know what they're doing, and can wrangle this stuff. So, and I think that's an opportunity. It's a massive opportunity. We see it as an opportunity. That's what we offer to our customers. It's like, you guys don't have to worry about this. We give you a great product.
That's the hard stuff that you do for them. And
exactly. Yeah. But you better be prepared to do that if you're going into this space, because it is certainly, particularly the hardware space, and dealing with embedded, they're not really embedded systems, but certainly these edge IoT systems that have an OS on them. Most of them are Linux. So you need to wrangle that. You need to make sure that things have drivers that are compatible. Your hardware. Things aren't turnkey, let's say, at this moment, but they're definitely better than what they were when we first started, for sure.
Yeah. And so future for Tiliter, where do you guys go next? Are you going to take over other industries, or vast numbers of other applications, or?
Yeah,
where do you head?
For us, I think the short term is pretty clear. We're pretty focused on we're doing quite a lot of work scaling what we have you'll start to see, keep an eye in your local store. You'll start to see a lot more of our systems out there, and that's consuming us quite a lot at the moment. Actually delivering that next wave. As you mentioned at the start, there was a time where we were working out of garage. We've built a lot of this stuff from the ground up, particularly in a space that was quite new. So we're in the process of kind of maturing that right now. Like, if you look at the next 12 months, it's about really building for scale. And then it's really scaling the products that we have. We want to see this recognition in every store in the world. It should be a day where you go to your checkout and your self-service checkout, or whenever you place items down, and it's like you're scratching your head if you have to use a lookup menu, because it's like, oh, this is still running on this old system, is it? Where's the recognition technology?
I'll go use the new one. I'm going
to go use the new one. Yeah. We always use the example of PayWave. When PayWave first came out, it was kind of like, oh, this kind of new technology that some people were willing to use and some people weren't. And now, if you go into a store, I don't carry a wallet. If I go into a store that doesn't have PayWave, I'm like, what the hell's going on? Where's the new tech? So we want our tech to be in that space where you go into every store. And it's the same problem for every store in the world. That being said, obviously the backbone of what we're building has a lot of application elsewhere. And like I said, we already do nuts and confectionery and various things like that. The core technology itself has a wide application, so we can use it in even hardware, recognizing items and different things there. That the processes that we build support that. But we're pretty focused. It's a big opportunity space, and we want to get it right. and it's pretty deep. So yeah, expect to see more of Tiliters recognition in your local supermarkets. That's really where we'll be focusing in the short and medium term.
You got to get it to recognize crumpled barcodes, because I've had a few times when I've been trying to like straighten the barcode out to get the barcode reader to actually recognize the damn barcode. So
yeah. Well, I mean, it's something that it's also probably, if you look at that sort of medium term horizon, even barcode items. I mean, the core technology itself is able to do that. We don't really focus on that area right at this moment, but it's certainly something that we've experimented with in the past, and we know the tech can do it. But there's a lot right now. The value prop for us is those loose items. We're really speeding up that process.
Yeah.
And doing that cross check. But it's a good point. I know the crumpets. Yeah, the crumpets always. Even by crumpets, they're always
folded over, and you're like, yeah.
I know this from when I was a cashier. That was the thing. It's like you haven't got to stretch out the bloody crumpet thing and scan that through. So yeah, it's a bit of an opportunity. Who knows?
Yeah, awesome. Well, thank you, Chris. Look, I'm gonna throw it open for more questions. So if you've got any questions that you've been waiting to ask Chris, please do put them on. It's been great talking to Chris this afternoon. I think you'll agree we learned a lot. Learned more about retail and scanning than I thought I was going to. So that's pretty good. Now I think I'm an expert. Actually, so I think it's NCR are the guys that have the ones at the self-serve checkouts at Woolies. Can you please kick them off, Chris? Because they don't work very well. They're always, misidentifying my produce, and I'm having to go through the menu.
The recognition level is quite a lot higher, you'll find, on our scales than you'll find at the self-service checkouts right now.
There's always biases towards something more expensive than it actually is. It's always trying to tell me I'm getting organic bananas when I'm just getting normal Cavendish.
As I said, watch this space. It's happening. It's slowly happening. So absolutely.
Fantastic. Okay, I'll give a couple more minutes in case anyone has any questions. And I'm not even waiting a couple of minutes. I'm impatient. And Chris, looking back, just thinking about AI and ML, did you have any idea you were going to end up doing this stuff? Was this something that you were kind of, back when you started working, were thinking, I'd like to get into that space?
I must say, not necessarily. For us, as a founder, for me personally, I've always just, it's an interesting problem. I think, for me, it's always about, solving interesting problems. I would say I always had a passion for algorithms and signals, systems processing. As I said, I'm an electrical engineer by trade. So that was my, first, journey in engineering was learning, signals and systems. But I always found, as I mentioned, I've got a massive passion for music. And the signal side of that, if anyone's familiar with signals and systems, system modeling, control systems, there's a lot of crossover between that stuff and what we do in ML. So the mathematics is the same, right? It's all matrix algebra that governs the backbone of that. It's data, training systems, cost optimization. There's a lot of parallels between what happens in, say, control engineering, which I did my master's in, and in this space. So the short answer is not really. But we dived in. This was for me and for us as a team. This is an opportunity, time for opportunity. There's very few times, there's always something, but you've got to pick the right one. There's a lot of stuff happening in crypto now, for example. That's probably a timing thing. This computer vision, AI, and edge for us at the time when we started the business, like, hey, we want to start something here. We're chasing, where the most interesting problem is. So that's where we are. We're about solving problems, and this was one that we saw was a massive. It's one of those ones where it's like it's such an obvious problem, but it hadn't been solved. We didn't see this the solution, so we thought, let's build it.
There is one more question, which was about the scan and go. Will it detect if we were to remove items from the basket if we're shopping for something? So if it doesn't unpack. So I think if you haven't used scan and go, I guess that's a question about, is it just detecting stuff you put in your basket? But do you want to explain a little bit how scan and go works quickly? So scan and go. So it won't detect if you take it out. So it's basically you scan as you go.
through your shop. So scan the item. If you choose to not check that item out, you can delete it from your cart. So it basically keeps a running, shopping cart on your phone, and you'll need to remove that out. If you decide to put it back and not, you would just remove it out. So there are obviously, one of the big challenges is the opportunity for theft and things like that. There are techniques, and if you've ever used the system, you'll know that they do random spot checks on the way out, and there is some algorithm behind that as well. So you'll find that it's not totally random. There are some factors there that sort of try to limit that theft factor. So it's something that's definitely worth thinking about when you're doing that shop.
Yeah. So it's not quite the take a photograph of your basket and choose things. Choose what's in it. No.
Yeah, that's right. So basically, as soon as you take the item off the shelf, your phone turns into a barcode scanner essentially. And you scan it, boom, put it in, and then on you keep going again.
The reason it's attached to a scale is that you put it on the scale where the photograph, so it recognizes what's on the scale and then gives a little barcode that you can kind of scan with your app, that then says this is the weight for the item that you've got, because of course they sell most of these things by weight. So
that's right. So basically our scale, it's part of that process. The part of that process it's involved in is, as you mentioned, recognizing the item, combining the weight or the unit. So some of those are sold by unit. It'll be all embedded in one barcode, so you can scan it. Whereas in the past, the process, and it was a really big blocker for that technology, was actually you needed to go scan, and it was a terrible user experience. That was the biggest complaint that was coming out of that. Was, okay, I have to go and scan over at the bay area where the fruit is, and then have to go over and get the weight. Now it's one process, and you would kind of have to do one item and go back. Now you can do it all in one go.
You can do it all at once.
One system. Yeah,
much easier. Okay, everyone, thank you very much. It's been a great session. Thank you, Chris. It's been wonderful chatting with you. Thank you for joining us, guys. As usual, it'll be up on our YouTube channel later if you've got friends you want to send the link to. Hope you have a wonderful afternoon. And Chris, thank you for chatting to us.
Awesome. Pleasure. Thanks everyone for joining.
See you later. Bye, guys.
Bye-bye.